Hey guys, welcome to your COMPSCI 1MD3 tutorial this week. Friday afternoon tutorial. So yeah, let's get started. And I can turn my camera off, I think actually. Let me share my screen instead. There we go. And I'll just minimize my cam. Awesome. Cool. Yeah, so I thought I would start today by just talking about that Avenue post that Nick made recently, just to make sure we're all on the same page. Yeah, so if I navigate to the announcements, and as you can see, Nick made an Avenue post where he mentioned that we've done a few things, keeping in mind that this is an online course. There was probably a lot of stuff you guys have going on, and you guys probably spend way too much time in front of a computer screen now. We wanted to make the course a bit easier on y'all. So we'll now be dropping your lowest assignment grade from your total calculated grade. In addition, the assignment TAs will be going through all of the assignments and taking out a few questions or converting them into bonus questions to reduce the workload. Also, we're going to make the midterms a bit easier on y'all. In addition to that, there will now be a 3-day grace period on all assignment submissions. So I really hope that makes the course a bit easier in terms of your workload and just all the stuff you guys are trying to balance. And if not, well, let us know then, and we'll work with you individually to try to reduce your burden. Cool. Yeah. So as you guys know, there is a midterm on October 4th, and Nick posted a practice midterm that you guys can go through to help get you ready. So we actually did a few of the practice midterm questions last week, but we can do a few more today, and then we should be ready for the midterm. Cool. Okay, so as usual, you can go to the Avenue post, and you can access the slides for today. Cool. And then you can just scroll down to some of the questions. But just to talk about the midterm once again. So the midterm will be very similar to just a regular Jupyter Hub assignment. So it'll be on Jupyter Hub, and you can complete all of the questions. So once again, you'll be asked to complete missing functions and such. You can submit the midterm on both Jupyter Hub or Avenue. Just as long as you submit somewhere, we'll make sure to mark it then. And once again, the midterms will be automatically checked for plagiarism. So please try not to copy code or share code in like a group chat or anything. Try to just be more indigenous on it. Cool. Okay, so to practice for the midterm, we have all of these questions. I think question 1 and 2 are pretty easy. We should be beyond that by now. And question 3 and 4 and 5, we actually did last week. So instead, we can start off with questions 7 and 10. So both of these questions are actually questions in the practice midterm on Avenue, which I'll just go to really quickly, just in case you guys have not seen it yet. But on Avenue, Nick posted a practice midterm to help get you ready for the actual midterm. So if we go to COMPSCI 1MD3 and go to content, and we can go to midterm 1 and practice test master. So I took out a few of my favorite ones and put them in the slides. I think we can start off with the Roman question. Roman numerals. And essentially, in this question, what we have to do is we have to make a function called Roman that takes a number as input and outputs the Roman numeral equivalent to that number. So for example, if my input is 39, my output would be XXXIX. Cool. Okay, let me just check the comments very quickly. Oh, perfect. That's the first question we're going to do, Nicholas. Awesome. Yeah, so let's get started on Roman numerals. So if you already know this question or have an idea how to do it, you can feel free to work ahead. In my opinion, the question is pretty easy, But I imagine the main stumbling block is you guys might not be that familiar with how Roman numerals work. So let's just go over that one time. It's a relatively simple algorithm. Okay, so let me put this into present mode. There we go. Yeah, so the algorithm is pretty simple. So with Roman numerals, we are no longer working with a base 10 system. Instead, we work with a different base system. So as you can see here, we have this Roman numeral map that shows the letter equivalent for all of the numbers. So for example, 1,000 in Roman numerals is an M, 900 is a CM, 500 is a D. So we have this really useful map that we can actually copy into our code because we can use this map when converting from a number to a Roman numeral. So in order to do that conversion, all we have to do is start off with our number. So let's say our number is 1984, and I want to convert it into Roman numerals. Well, the first thing I'm going to do is I'm going to go through my map, and I'm going to find the biggest number that can fit in the number I'm converting. So if I'm converting 1984, what is the biggest number in this list that fits in 1984? Yeah, so the biggest number is 1,000, which means the first character in our Roman numerals equivalent will be M. And that 1,000 has now been represented. So now we have 984 left that we need to show in Roman numerals. So once again, I have this remainder of 984. I'm going to go through my map and find the biggest number that fits inside 984. So the biggest number that fits in this map is 900. And 900 in Roman numerals is CM, which means the next number that we represent is CM. And now we have a remainder of 84. And so once again, I have to go look through my list and find the biggest number that fits in 84. And then I continue and keep going until all of the numbers are represented, and I have a remainder of 0. Okay, so I'm going to give you guys 3 minutes to get this question done, and then if you don't get it, no worries, I'll take it up right after. And yeah, to help with the dead time, I'm playing jazz in the background. But if you guys have any other music suggestions, feel free to let me know. Or if it's just kind of annoying, let me know too, and I'll turn it off. But I figure it's a good way to kill dead air time. Okay, so 2 more minutes to get this question done. Yeah, so all of the previous tutorials are all on my channel, Kenza. So if you actually go to my channel and just go to the actual channel page. And if you scroll down to the COMPSCI 1MD3 tutorial playlist, you can find all of the tutorial videos on my channel. Cool. And I can add today's tutorial right now, actually. If I just go onto YouTube. And I can add today's tutorial as well to the playlist. Okay, so let's start this Roman numeral question. So the first, most obvious thing we can do is we can copy this data structure into Python. So I'm just going to make a new Python program. And I'm going to save it. I'll save it as Roman, I guess. Roman. And I'll save it under work, under COMPSCI 1MD3, fall. And there we go. Okay, and so I'm going to copy this data structure into Python. I'll just type nummap, and that's equal to my data structure, which is a list of tuples. So tuples are like lists, except they're just immutable. So it's copying in the Roman numerals map into my Python code. Okay, so we have M, CM, T, CD, XC, L. No, I missed one. CD is 400. Then C is 100, and then XC, that's 90. 50 is L. 40 is XL. 10 is X. 9 is IX. 5 is V. 4 is IV. And 1 is I. Cool. Okay, and before we start off making this function, I just want to go over the for loop once again, just to make sure we're familiar with it. So a for loop is a really easy way to iterate through a list or any series of elements in Python. So with the for loop, I can just say for some variable name, let's suppose E, in nummap, and then I can access all of the elements in nummap one at a time. And I can show this by printing out the E value. And if I run this code, it'll print out all the values in my list. Now here's the thing. These values themselves are data structures, or a series of elements. And I don't want to just access the tuple individually, but I want to access these specific elements inside the tuple. So how can I access these specific elements inside of the tuple? What can I do? So I absolutely can use string indexing. And so by that, I mean, instead of just typing print E, I can type print E, index 0, and then print E, index 1. And now I run the code, and I get the elements individually. So that's a totally legitimate way to access the data. But Python is so simple and intuitive that instead, if I know that the element itself is a sublist of a specific length or a sub series of a specific length, I can just type in the number of variables equivalent to that length. Right, so if I type in for IR, in that way I can access the elements in the same way. So it's the exact same code, exact same result, and we can use either indexing or we can just pass in this type of for loop syntax instead. Okay. Okay. So let's start making the for loop function now. So it says I have to make a function called Roman. So to make a function in Python, I just have to type in def and then the function name, which in this case will be Roman, followed by brackets. And inside brackets, I place the parameters that I'm passing in, which in this case is some number variable. So let's just call it num. Cool. And then what I'm going to be outputting is I'm going to be outputting a string that contains the equivalent Roman numerals to that num. So to start off, I can just make some blank string. Let's say, Roman conversion. That's equal to an empty string to begin with. Cool. And then what I can do is I can just iterate through I can just loop and repeat this algorithm that we see here until we have finished converting all of the numbers. Okay. So I can make a while loop, and I can say while num is greater than 0. What I want to do is I want to loop through all the elements in the map, and I want to find the biggest element here that fits inside num. And whatever that biggest element is, I'll place the equivalent Roman numerals inside my string. Okay, so I'll say for I and R in the num map, and I'll say while num is greater than or equal to I. So while my number value is greater than this value, if this num map value fits inside num, then what I'll do is I'll add the Roman numeral equivalent to the string, and I'll minus that I value from num. And then I just can return the finished Roman numeral. Cool. Okay, let's test this out. So how do we test it out? With a print statement, of course. So I can print out Roman of, and I think the example was 1984. 1984, there we go. All right. And then I can run my code. And we get MCM LXXXIV. And yeah, that seems equivalent to me. Awesome. So let me just pause right there for a second to see if anyone has any questions. Don't we need to import nummap into the function? So nummap is a variable, Alex. And so any variable defined in the Python code is accessible to anyone, anywhere in the function. So I don't need to import it in. It's not like a global variable or something. If I want to, I can define nummap inside here too. If your opinion is that like the scope shouldn't be accessible to anyone. So yeah, but yeah, the scope of a variable here is accessible to anything else in the Python program. Do I and R stand for each pair? Yeah, so I and R are just variables that refer to the indexing. right? So in the same way that we can have a for loop saying for e in some list to refer to each element of that list, likewise, we can, if we know that the sub element is a tuple or a list or something else of multiple values, we can refer to those values directly. So if this is confusing, I can instead just say like for e in nummap and change I to e of 0 and r to e of 1, and I get the exact same code. See? Okay, cool. Awesome. Yeah, so maybe I can talk about how this for loops work in a bit more detail, if that's something that some of you are stuck on. So let me open up my idle menu, and I can code a bit more quickly there. Yeah, so let's suppose I have some list L that has plenty of tuples. Actually, I think it'll work. Yeah, let's do tuples first. How about that? So my list is composed of a series of tuples. So we have tuple 1, then we have tuple 2, and then we have tuple 3. And let me just change up these values a bit. Oh, sorry. And let me not forget the equal sign. Cool. Okay, so we know, of course, that if I want to access one specific element of a list, I can just use the indexing. So L of 0 will give me the first element here. And so my sub element can also be referenced or broken down by indexing. So if I want to access the first element of this tuple, I just add in a second set of square brackets, and that gives me the 1. Perfect. And likewise, I can make a for loop to iterate through L. And that lets me iterate through all the elements one at a time. And if I wanted to access the specific elements within each tuple, I can just reference them by index. But that might be kind of tedious and clunky, right? That might not be as convenient as we want it to be. So instead, what I can do is I can just pass in some variables stand for each specific value. So I can make these variables any name. I can call them A, B, C. I can call them X, Y, Z. It does not matter. But as long as they're the same length as the sub-element length, then Python will know how to map the variables to the tuple. So this is just another way to use the for loop. But if you feel more comfortable just having one variable and then indexing, that's totally cool too. But this is more similar to dictionaries, which we'll be talking about next week, and like key value pairs. So I thought it was good to bring it up. Yeah, so in my opinion, the practice midterm is tougher than the actual midterm. So I think as long as you can do all the questions in the practice midterm today, Hamza, you should be ready. So just try to get them all done, and you should be good to go. But in my opinion, the best prep for the practice midterm is just to do the Jupyter Hub assignments again. Okay, so Natty asked about question 1 on the practice test. Okay, so let me take a look at that, and then I have one more question left in the slides, so we'll try to do both. Okay, so you write a function, num increasing, that takes as input a tuple of numbers and returns the first sequence within the tuple that is increasing order and has length at least 2. You can assume such an increasing sequence always exists. This is an interesting one. Okay, cool. Yeah, okay, cool. So I would use probably a while loop to iterate through that, but that's cool. Okay. Nice. Okay, yeah, sure. So Natty, how about we do the GCD question first and then we'll start the num increasing one. And yeah, if and then if we don't finish it in class, you can just email me personally, Natty, and I'll send you the solution directly to your email if that works. Cool. Okay, so let's do GCD first, and then if we have time, we'll get to the num increasing one. Okay, so with this question, we have to make a function called GCD. GCD takes two ints as input and outputs the greatest common denominator of the two ints. So relatively simple question. Take a few minutes to get it done. How about till 4:58, and then I'll take it up. Okay. And I will check the comments in the meantime. Will we have the whole day to complete the midterm, or is it just a set amount of time when you begin? We'll be on Jupiter Hub. So I think you have until like 11:59 of that day to get it done. It says an avenue though, doesn't it? The specific time. Okay, if I go to announcements, midterm. Yeah, so you'll have 24 hours to complete it. Okay, let me check the syllabus. But yeah, I'm pretty sure you have until midnight to get it in. At least that was the case with last semester. But we can just double check while you guys are finishing the GCD question. That one's a bit easier than Roman, so I think we should get it done just fine. Yeah, so you'll have 24 hours to complete each test. Um, you have the full day. It's not like a time limit from when you open up the midterm. And it's also an open book test, right? So you can use online resources. Cool. Okay. What was that question that the student had? Okay, just a few more minutes to get GCD done. Okay, one more minute to get it done, and then we'll take up Natty's question. Yeah, so it's funny because that num increasing question is a pretty common one, but usually you don't find the first increasing list. Instead, you're supposed to find the biggest increasing sublist. So that changes how it works a bit. Okay. All right, let's get this question done. Yeah, so let's do the GCD question. Okay, so yeah, pretty simple question. So all we want to do here is make a function called GCD that has two numbers as input. So what I'm going to do is I'm going to make a new Python program, and I'm going to save it. I'll save it as GCD, and I'll just make a new function called def GCD, and GCD has two numbers as input, n and m. Okay, and so the next thing we have to do is we have to find the greatest common denominator of n and m. So what do we know about the greatest common denominator? Well, the greatest common denominator is the biggest number that's a multiple, or sorry, that's a factor of both n and m. So if it's a factor, what does that mean? That means that the factor, the GCD, has to be less than the smaller of the two numbers, right? So for example, if you want to find the greatest common denominator of 5 and 10, well then I know that any factor of both numbers has to be smaller or equal to the smaller of the two numbers, right? You can't have a number that's a factor of something that's a number can't have a factor that's bigger than itself. Okay, so the first thing I'm going to do is I'm going to find out which number is smaller of n or m, and I'll do that with the min function. So what the min function does is if I pass in multiple values, let's say n and m, it will return the smaller of the two values. So I'll make min equal to some variable. Let's call it smaller. Cool. Okay. And then the next thing I want to do is I want to make a for loop that just iterates from the range that starts off. So I want my range to be going from bigger to smaller, right? Or I guess I want the range to be going from the smaller value all the way to 0. I want to check all those in between values. So for example, if I want to find the greatest common denominator of 5 and 10, I want to start off by checking the numbers 5, then 4, 3, 2, 1 to check all the possible factors, right? So I'm going to start off with my range at smaller. And then my other side of the domain will be 0. And of course, I'm going to be stepping backwards. Okay, how about I just print out what these values are just to make sure we're familiar with them. So let's call my function print GCD of 4 and 12, or actually what the example was 12 and 20. The example is 12 and 20. There we go. Okay, so I'll run the code. And yeah, so it prints out all of the values. And I guess it prints out 0 as 1. But anyways, so we're going to make so we're going to make our Python program that starts off at the smaller value, which in this case is 12, and it keeps on printing out values till we get to the end. And then next, what I can do is I can just do a simple if statement comparison, where I can say if n mod of I is equal to 0 and m mod of I is equal to 0. Well, if that's the case, then I know that my value that I'm testing is a factor of both n and m. And since I'm starting from the largest factor, potential factor, to 0, I know the first number that's a factor of both will be the largest possible factor. So I can just return this value. There we go. And I get the biggest factor, which is 4. Awesome. Okay, let me check the questions. You have 9 a.m. Saturday to 9 a.m. Sunday. Oh, perfect. Okay, awesome. 9 a.m. Sunday. Yeah, sure, that works too. It's pretty hard. Yeah, the practice test is tougher in my opinion. Okay, so let's do that question that Natty was talking about. Yeah, so we can do this with like a basic for loop, in my opinion, right? I'm going to be making this up on the fly, so I might get it wrong the first couple of times. Okay, so let's suppose that we have our Python program. I'll make a new Python program. And I will have my question here. Okay. I'll download this actually, just to make it easier. Oh, God. Okay, and I'll save this as num increasing. Cool. Okay, so I'm going to make my new function def num increasing, and this takes as input a tuple. Okay, I'll call that t. Okay, so we're going to have to output a tuple itself. Yeah, so this question's kind of silly because if they gave us a list, it'd be easier to work with the data. Because as we know, tuples are not mutable. So for example, once I make a tuple, let's say it's like, I don't know, t is equal to, oh my God, let's say it's t is equal to 1, 2, 3. I don't think we can change the tuple values, right? So I can't change t of 0 to be equal to like 3, right? Because the tuple is not mutable. Unlike a list where we can change that value. So even though we have to return a tuple, for now, I'm going to make an empty list. Let's just call that output. And it's just equal to an empty list value. And so what I'm going to do is I'm going to iterate through all the values in the tuple. So I'll say for I in range, the length of my tuple t. And then I am going to be saying, so I want to see if two numbers are increasing, right? So I can just say if my tuple value, how would I change this to nums? That's a better variable name, by the way. So I can say if nums of I plus 1 is greater than, when it says equal to it, that has increasing order. So yeah, like greater than or equal to, because I assume if they're equal, then it doesn't matter, is equal to nums I. So if that's the case, then we know that both numbers are part of the tuple then. And so then we should add both to the tuple. But we have to consider the fact that if it's the last number of the tuple, then we get an indexing error. If we try to call nums I plus 1 and I is equal to the length of the tuple. In addition to that, we want to add only one number at a time, right? Okay, so what we can do is we can say if out, so if out is already defined, then we should add both. We should add just the most recent number, right? So we should just say it's out dot append, and then we can add like nums I plus 1. But if out is not defined yet, in that case, we should add just one of the numbers. So we should add both of the numbers. So we should do that and that. Okay. All right. And then we need to have an additional else statement. Need to have an additional else statement saying that if or we should just check to see if it's not equal to 1, right? Or because we already checked the last. So I think we can just make this go to like length of nums minus 1 then, if we're checking them all anyways. Okay, so this will just give you all of the increasing numbers. We want to break this off as soon as nums, as soon as it stops increasing one after another. So I guess what we should say is, so if it's not increasing, but out is defined, then break. So also if it's not increasing, but out is defined, then return out, or just return out once you're done. Okay, so I think that's it. I'm not totally sure, so let's try this out, okay? All right, fellas. Okay, so what's our example? So print, oh, this is going to be returning a list, by the way, but you can change it to a tuple at the end. Okay, so print num increasing, and it's a tuple, so like that. 5, 2, 1, 3, 4. Oh, okay, let's try this out. You get 1, 3, 4. Okay, so is that the, yeah. Okay, that seems right. Okay, let's try, oh, let's just try them all at once. How about that, actually? Probably a better idea. Okay, so next check is 21456. 21456. And then it's 189, 10, 100. 1, 8, 9, 10, 100. And then it's 4, 1, 2, 3, 4, 1, 2, 3. Okay, let's hope there's nothing bad happening. Okay, I think we got one wrong. Okay. So 1, 4, 5, 6, 1, 8, 9, 10, 100. Oh no, it seems right. Okay. So this seems right to me, yeah. But I didn't check to see if it's an official solution. So like there might be like an edge case I'm not considering. Maybe I can check the comments if you guys have any advice. So let me go to StreamYard. Oh shoot. Let me go to StreamYard. And there are new comments. What does if out mean? Yeah, so that's a good question, Hamza. So I thought to get around that, we could. So I thought, so we're not going all the way to the end of the list. We're going to the second last element, and that's why we can still do I plus 1. So yeah, good catch, Hamza. But we're doing length of -1, so that should make us good there. Okay, what does if out mean? Yeah, good question. So if out. So here we're just saying that if the basically what we want to check is we want to check to see if this is the first element we're adding to the list, right? So we're checking to see if the out value is defined. So either out is defined, in which case it's not equal to null. There is values inside of the list. So if out is essentially the same thing as saying if out is not equal to null. So if out is not empty. And we're doing this test because we want to see if this is the first time that we're adding values to the list. If it's not the first time, then we can just add the next value. If it is the first time, then we have to add both values. So does that explain things, Hamza, or is that kind of a complicated answer? But yeah, essentially, if out is the same thing as saying if out is not equal to null. It's saying if out is equal to true, and true just means that the variable is defined. So when a variable is equal to empty, it's null, it's considered not defined or false. Right? So for example, if I have a variable, let's say s is equal to a null string, then s is false. S is not defined because there's nothing in s. If I typed in bool and I passed in s, I should get, I believe, a false back. Yeah, you get false back, right? However, if I change s to be equal to something, anything, like anything at all, then s is true because s is considered to be set. So this is just a way to simplify your if statements. But yeah, if I wanted to, I absolutely could just change this to saying if out is not equal to false. Likewise, if out is not empty. Okay. All right. Any questions left, guys? So Nicholas asked to do. Yeah, awesome. That's good to hear. Yeah. So in my opinion, I think the best gauge of difficulty of the midterm will be the assignments. That being said, I would rather you guys overstudy than understudy. So just make sure you can do all the practice midterm questions in addition to the assignment questions to make sure you're ready for the test. I'm a bit of a hypocrite there because I have a midterm in like 1 hour, but I've yet to study. So and I want to talk about doing all the practice questions. But yeah, so in my opinion, the assignments are better measure. Okay, then I know that someone else asked for question 8D. So I don't think there's enough time to take up 8D today. But if you can't get the question, Nicholas, just email me and then I'll take a look and I'll send you a solution. Okay? Does that sound cool, Nicholas? All right. So yeah, I think class is almost done today. So if there's no additional questions, yeah, sure, you can email me. I have a midterm in like an hour, so probably won't get back anytime soon, but I should get back to you like Saturday or Sunday. Actually, you guys have your midterm Saturday, so yeah, it might be a bit tough on timeline. Yeah, cool, no worries. Thoughts on Haskell? I don't think it's on the. I don't know. Might just study everything. Study everything. Okay. All right. So if that's no more questions, I will log off then. Yeah, if you guys send me any emails right now, I'm gonna be a bit busy for the next like few hours, so I might not be able to get back to you too soon. But yeah, so good luck on the practice. Good luck on the midterm tomorrow. In addition to that, this practice midterm has been on Avenue for like years now, so all the solutions are on like Stack Overflow and Chegg and such. So if you guys do a bit of digging, you can probably find a solution too. Just look around there. If I'm not able to get back to you, I'm immediately on that. Okay, cool. All right, take care, guys. Have a good day. Bye. If there are no additional questions. Take care.